Hi, welcome to another video. In this video we are going to solve problem number 424, that is longest repeating character replacement. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. What they mean is they will give a string and a number k. We have to replace some letters from the given string so that we can get a substring with all these characters which are equal to each other. So consider this first example where the given string is AB. So given k is 2, this means we can replace any of the two characters from the original string to a English uppercase letter to get a substring of maximum length which contains all the characters as the same. So if we replace B, this B and this B with A, because we are replacing two times because k is 2, then we will get a string which consists all the A's. So the output will be 4. Let us consider the second example where the given string is AEBA BBA and k is 1. So this means we can replace any one character from the given string to get a substring with maximum repeated characters. So if I replace this B, that is k is 1, we can replace any one character. If I replace this B with A, then our string becomes AA and BBA. So if you observe this string, the substring with the maximum repeated characters length is 4. So this is one such string. What we can do is we can also replace this A also. So if I replace this fourth A with B, then our string becomes AA, then 4 B's and A. We replace this A with B. So then also we will get a substring with 4 repeated B's. Here also we will get a substring with a length of 4 which consists all the characters as B. So this is the explanation regarding the problem statement and how can we arrive at this solution. So what is the length of the maximum substring length which contains all the characters as the same character? So in order to find that, one way to do it is we can find all the substrings and then we can check what is the maximum length of the substrings where all the characters are equal. That is one way to do it, but generating all the substrings will take O of n square time complexity, and then once again we have to go through it for finding the repeated character count. So instead of doing that, what we can do is we can maintain a dictionary named count. This dictionary will contain mapping from the character, that is from A to Z, from character to count, number of times it appears, and then we will maintain a sliding window which will be represented by left and right boundary. At each point we will try to increment the R. Whenever we increment the R, we will try to add that particular character to the window. Whenever we add a particular character to the window, our count for that particular character will also increase. So then we will check at each position whether that window is valid or not. So we need to replace some characters. So what is wise thing to do here? If we have let us consider this substring for example. Let us say we have this substring AABA. So in this, if we want to replace some characters, we will not go for the characters which have higher count. So if we want to replace all the A's, then we have to do it 3 times. If we want to replace b, then we have to do replacing operation only once. So we will not go for the characters which have the maximum count. So our window length, that is the length that we are going to consider, minus the max of counts. Max of count values should be less than or equal to k. So what this condition means is we can still replace k characters from the window to get a substring of length, window's length. So what I mean is, if we have a substring, let us consider that substring as well, where let us say this is the window that we are going to consider. So if we have this window, our window length is 4 because we have 4 characters, and the maximum count in this window is 3 because a appears 3 times. So difference between these two is 1. So 1 is less than or equal to k. This condition ensures that we can replace one character because we are allowed to do that. So that condition is true, then this window becomes valid because we can replace b from this string to get all a's. So this is the condition that we are going to keep in mind while writing the solution. Once we write the solution, we will go through the time and space complexity. Let us start writing the code for the solution so that this explanation becomes little more clear to you. As I said earlier, initially we are going to initialize a dictionary which does not contain any characters. Then we are going to declare 2 pointers, left as 0. Initially both will point to 0. So for write in range of len of s, then we will start adding these characters to the count dictionary. So we will have a character indicated by the right boundary of the window, that will be s of right. So count, this is a dictionary, key will be the character. So s of right will be equal to, what we can do is count dot get. This method will return the count if it is already present. Otherwise we will mention a default value of 0. What this will do is, if s of right key is present in the count dictionary, then it will return that count, otherwise it will return 0. Then we have to add +1 for that, because we have found one more character. So after this, now we have the character counts in the dictionary. Then we can check whether our window is valid, while our window length, that is, first is the window length, that is defined by right minus left +1. This will give the window length, and minus the maximum count which is present in the window. So our window character count is represented by this dictionary. So we just have to get the maximum value which is present in the dictionary. Maximum of count dot values. Count dot values will return the list of all the counts, and max will return the maximum among them. So we are taking this difference and this difference. So we are going to use one more bracket here. Okay, this difference, if this difference is greater than k, that means we do not have a valid window. So what we should do is, we should pop characters from the left of the window. What we are going to do is count of s of left. Since we are removing that character from the window, we need to decrement the count as well. So we will decrement the count, and then we will increment the left boundary of the window. So this will keep on going as long as our window is not valid. our window is not valid because with the given k we have to replace more number of characters from the window to get a valid window. So that is why we started removing characters. Once we do these things, then our window becomes valid. So then we can check. We have to update the max len. We will declare a variable and initialize it to 0, and then we will try to update this value. Max of max len. This represents the current value that max len is holding and the current window length, that is right minus left plus 1. So this is the approach behind calculating the proper window length. Then we will return the max length. Let us submit this solution and check whether it passes the initial test cases or not. Yes, as you can see here, this solution is passing the initial test cases. Before submitting the solution, let us discuss about time and space complexity. For time complexity, let us discuss the time complexity first. For time complexity, we will go through the list once, that is O of n time, and here we are doing one more thing, that is we will get max count also for each time. That is, we know that our string consists only uppercase English letters, so this dictionary keys will be from A to Z. So in order to get the max, it will take at least from 0 to 25, that is from A to Z it has to go through to get the count. So our time complexity is, we will go through n into 26. This 26 comes from here, that is O of 26 multiplied by n. So this will in turn become O of n. And for space complexity, so we are using a dictionary to store a current characters count. So we will use, this will be proportional to our string size. So not the string size actually. Anyway, there are only 26 characters. So this will become O of 26, which will result in constant space complexity. Our space complexity is O of 26 actually. We can write it as constant space complexity. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithms, then you can check out other videos from my channel. Thanks for watching this video.